Thank you for being here. I see there are at least a few teachers here, right, Dr. Dan, Jeremy? Okay, so I have a question for you. Isn't it annoying when your students arrive late to class? Or when they don't come to class? And isn't it annoying even the process of checking if they are on class? Yeah. Well, I'm afraid to tell you your students will keep coming late to class, but with our project, you won't have to worry about checking it. We have created the ACE box, which stands for Attendance Checking Embedded Box. This is our prototype. You can see it has a screen, a speaker, and an SD card slot. And this is how it works. The students, everyone has their own ID, and they're going to swipe it in the box when they arrive to class. What? Yes. Yeah. So they will swipe their cards on the box when they arrive to class. And then every time he wants, the teacher can check the data about attendance, just going to the SD card and reading an Excel file. So the teacher doesn't have to know the processes that go behind the scenes. He just has to deal with the Excel file. So that's why the interface is user-friendly. And this brings some advantages. For instance, it brings precise statistics about attendance on class, which makes it possible to do a more precise evaluation of the students. Then it doesn't use any extra materials. It just uses the ID cards of the students, but it provides an extra functionality to it. And it provides also less time wasted in class, so because the teacher doesn't have to check in that the students are in class. And above all, it is a more secure method than the ordinary checking procedure. So this is what the teacher is going to see inside the SD card, an Excel file. The Excel file has data about the class, for example, the name of the class, the start time, the end time, and the day of the week that the class is held. Also data about the students, their names and IDs. And then there is a matrix with characters. These characters have information about the attendance. If the character is a 1, it means the student arrived on time to class. If the character is a 2, it means that the student arrived late. And if the character is a 0, it means that the student was absent that day. The end characters correspond to future days, so we have no data about that.
Okay, so while the functions and the functionality of the box make sense, I'm going to explain how the parts of the box actually came together to make it work like it does. First, we have the RFID Reader. This will read the student ID card and get the information inside it. The particular model we are using is able to read cards up to 10 centimeters away. We then have the real-time clock. This will give us the precise time and date in time, so we can know whether or not there is a class today, and if there's a class now. We have the microSD reader, which is housing a microSD with the Excel file that have already explained, with the student's name, class, and whether they're present or not. This will later be written on with this information. And we are actually using a 4 gigabytes SD card, which is virtually able to host tens of thousands of students in the same SD card. Most important of all is the Arduino Omega. The Arduino Omega is a central hub of our project. It's going to hold all the electronics together and communicate between them. And right now it's going to decide whether or not the student was late based on the information on the SD card and the real-time clock. So it compares this time and decides that. But just what is the exact definition of late or present? Well, there are the 3 options, 1, 2, or 0, being present, late, or absent. The first one, present, is being defined as arriving the first 15 minutes of class. Being late is defined as being after the first 15 minutes and before the last 15 minutes, so in the interval in between. And the last one is when the student either arrives in the last 15 minutes or he doesn't come at all, so he just doesn't swipe his card. And finally, we have the LCD screen. The LCD screen throughout all the process will display a message saying whether or not the student's late, present, or if no one swipes anything, you're just going to say like, have a good day and the time of the day. And now we have the actually physical assembly of our model. First, we have the electrical part. So this is the Fritzking sketch. Why we don't need to enter in details, it's important to see how Arduino is connected to every single component in your box. And here's the actual assembly of the box, part by part, how we did on real life. This exploded view was done on Autodesk Inventor, 3D modeling software. And you can see the box on the table right now. And we also made a video displaying how a real workday would go with the ACE box, like how a professor would use it. In our video, we show 2 students swiping their card and how the numbers are going to change accordingly, and what happens when the wrong card is swiped. So first you can see in the last column, the 2 ends being highlighted. Those are the 2 ones that are going to be shown in the video. So this means that the first student arrived on time in the first 15 minutes. And this is a bad card, it was just not recognized. And now James Brown was late. You can see how the number changes from n to 1 and n to 2. So this is what the professor would see.
So what's next? Our project is a functional design, so we can use it right now if a professor wants. It would serve for its purpose. But if you're going to look for something bigger, we could, with more resources, do some implementations that would make it better. Just like plugging a power outlet in which we wouldn't need to use the battery, that right now we would have to change it periodically and would not be that secure, that efficient. Other thing we could do is to connect the system to a central network, internet-based, in which we wouldn't need to take off the micro SD card and plug in a computer. In this time, during this, we could suffer an accident with the micro SD card, or the way it is, the micro SD card is easy to access for somebody else that could bypass the system. We also want to thank Professor Jeremy Hadek and Daniel Tomo for the support and help in our project. Also Joe Welling for the laboratory, mechanicals and everything. So now, Professor, do you want to buy one? Thank you.
One more time, we're gonna celebrate. Oh yeah, alright. Don't stop the dancing. One more time, we're gonna celebrate.